Hereby, I open this academic ceremony in which Petros Kalendralis will defend the academic thesis, Artificial Intelligence Application in Radiotherapy, the Role of the Fair Data Principles. May I invite you to present a summary of your study and the conclusions of your thesis before we go to the opposition.
Dear Rector, thank you very much for the introduction. Dear members of the Corona, dear colleagues, friends, and family, thank you for attending my PhD defense ceremony. Cancer is the uncontrolled growth of abnormal cells. These cells can destroy the organs where they grow in. Cancer develops when the body's normal control mechanism stops working. Initially, cancer cells grow into a tumor. Then the tumor breaks up and spreads around the body via the lymph or the blood system. This leads to metastasis or secondary cancer. Radiotherapy can be considered as one of the treatment options to treat cancer using ionizing radiation. How does radiotherapy work? The main functionality of radiotherapy is to damage the DNA and therefore kill the cancer cells. The main aim of radiotherapy is to deliver maximum radiation dose to the tumor while minimizing the radiation dose to the normal tissues. This gives the highest chance of destroying or reducing the tumor and allowing normal organs to recover. Therefore, a balance should be achieved between the tumor control and the healthy organs and the dose that goes to the healthy organs, as there is a high chance for side effects. The side effects are dependent on the tumor site. For example, for head and neck cancer, we have side effects similar to dizziness or difficulty to eat or swallow. Radiotherapy is a multidisciplinary area in which medicine, science, and technology come together. As a result, collaboration between different disciplines, such as physicists, clinicians, and technicians, is required. Nowadays, the field of radiotherapy is striving towards the improvement of automation and accuracy in the delivery of radiation therapy. Artificial intelligence, which can be defined as the ability of computers to perform tasks that require human intelligence, plays a key role on it. Furthermore, artificial intelligence has the potential to automate routine clinical tasks such as the quality checks of radiotherapy treatment planning or the prediction of radiotherapy-related outcomes. For the goals of my thesis, first, I had as a goal to implement AI methods that can be applied in the radiotherapy domain, and specifically in the subdomains of medical imaging, prediction modeling, and quality assurance checks of radiotherapy treatment planning. Furthermore, I had as a goal to transform radiotherapy-related data into machine-readable format, introducing the fair data principles to the radiotherapy community. In the next 3 slides, I will provide some examples from the chapters of the thesis where I investigated the potential of AI in the 3 above-mentioned subdomains of radiotherapy. Specifically, in chapter 2, I focused on the extraction of imaging features that can be used for the prediction of radiotherapy-related outcomes. This concept is known as radiomics. In this chapter, I provided guidelines for reproducible and standardized radiomic studies. Some of the important points included details about the definition and the hypothesis of the clinical question, the database selection, the image preprocessing steps that should be taken into account, and the feature selection method. I concluded that several standardization steps should be taken into account for the design of radiomic studies, as well as collaboration between clinicians and researchers. In chapter 6, I focused on the validation of mathematical models that are used for the selection of head and neck cancer patients candidates for proton therapy in the Netherlands. Proton therapy has the potential to reduce the side effects for the patients, and therefore the dose to the healthy organs at risk for the patients. How do we evaluate these models? We use the receiver operator characteristic curve, which is a graphical plot used to show the diagnostic ability of these models, and then calculate the area under this curve, which is abbreviated to AUC. A curve that is above the diagonal and reaches the highest point on the left side represents a good performance of the model, while a curve that reaches the diagonal represents a not so good performance. In this figure, I have presented the performance of different models that predict radiation-induced toxicities, the prediction of radiation-induced toxicities 6 months after radiotherapy of patients. As you can see, the performance of these models is good. I concluded that independent validation of AI algorithms is crucial for the clinical implementation of them, and specifically for the proton case in Maastricht Clinic. In Chapter 7, I validated an algorithm that can alert radiotherapy professionals for radiotherapy treatment planning errors. The algorithm was developed by an American institute in Washington in the US and validated at Maastricht Clinic. The results showed that the performance of the algorithm is not so good as was expected. I concluded that the technology of the patient and the patient characteristics in a radiotherapy institute can influence the performance of these AI algorithms. As you can see in the figure, the curve is approaching the diagonal. Research is the basis for a radiotherapy intervention that can potentially be implemented into the clinic. However, there are some problems that researchers face in their everyday life. Number one problem is the lack of resources among the radiotherapy institutes that can lead usually to lack of knowledge exchange. Furthermore, it's difficult for researchers to reproduce a research finding due to data exchange barriers. Finally, the most important problem, according to my opinion, is the different terminologies and languages used among the different researchers. Here is an example of two tables from two different hospitals from Poland and the Netherlands. As you can see, it is difficult to understand whether a patient is male or female. This can lead to a Babylon Tower-related problem. For this reason, I selected this cover for my thesis. A specific set of principles called FAIR data principles establish a common framework for researchers who face the problems I described in the previous slides. They were first specified in a publication by the National Consortium of Researchers, and the FAIR data principles act as an international standard of guidelines for high-quality data. FAIR is an acronym that makes the concept easier to discuss. FAIR data refers to data which meets principles of findability. Here the researcher wonders where he or she stored the data. Accessibility. Here the researcher complains why the data were not available in all the colleagues from the department. Interoperability. Here the researcher wonders why he or she cannot open the data file. And reusability. Here the researcher gives the data to another colleague. Sharing is caring. In the next two slides, I will describe how I achieved the second part of the goals of my thesis related to the FAIR data principles. In chapters 3 and 4, I transformed data coming from multiple hospital data storage sources consisting of clinical, radiomics, and imaging data into a machine-readable, FAIR format following the FAIR data principles. I concluded that the FAIR compliant data enable reproducibility among the radiotherapy community. In chapters 9 and 10, I focused on the interoperability aspect of FAIR, transforming data from the National Proton Therapy Registry in a machine-readable FAIR format using a graph structure. These graphs represent the relations between the data items that are connected with different predicates. As you can see, I have baseline, tumor, and treatment characteristics as data items. I concluded that FAIR-compliant data from the National Proton Therapy Registry can be represented in a graph structure called knowledge graph. So my thesis conclusions. First, as researchers, we have to reconsider the design of artificial intelligence studies following a common standardization framework. Second, the FAIR principles have an important benefit for the different radiotherapy stakeholders that will adopt them. And the last one, and most important in my opinion, the data preparation and transformation into a FAIR format is a labor-intensive task and time-consuming task as well. Thank you very much. Now I will give the word back to the prorector.
Thank you very much for this very nice overview. It was as simple that even a hematologist can understand what your work is, and it refers to your proposition number 8, where you state that if you cannot explain it simply, you do not understand it well enough. You did explain it simply, and now we have the opposition to challenge you how well you understand what's in your booklet. We will start the opposition by Professor Verhagen, who is a professor of medical physics at the Maastricht University, and he was also, or is, the chair of the assessment committee. Professor Verhagen.
Thank you very much. So first of all, congratulations on this very extensive and very deep digging thesis. That's really good work. And I also enjoyed a lot the front cover of your thesis, which for a Tower of Babel looks surprisingly stable to me, actually. Okay. I do have a few questions, and the first one is about chapter 3.
Yes.
So there you offer CT imaging data from 3 different CT scanners, from 3 different centers, and using 3 different phantoms, right?
Yes.
And I was wondering if the only use of that exercise was to eliminate unstable radiomics metrics, because that's what you focus on, eh?
Yes.
So yeah, it sounds like a good idea, but I'm wondering if you eliminate unstable metrics from phantoms, is there any guarantee that the remaining metrics are actually suitable for humans, where you have all sorts of like motion artifacts and so, which you wouldn't have in your phantom? Eh? So yeah, could you elaborate a little bit on that?
So the highly esteemed opponent, thank you very much for your question. So the idea for this experiment was to check whether we can make first a standardized CT scans of phantoms across different hospitals. And the idea was to check whether these scans will have a difference. However, the other goal was to provide radiomics publicly available data for radiomics researchers to reproduce these scans or take the data and take the data for their research purposes. However, the phantoms were the morphology of the phantoms was really simple, and we didn't take into account the artifacts that maybe will be in these scans. However, there are different artificial intelligence algorithms that remove these artifacts from the patient scan, let's say, and not the phantom scans. So the overall goal was to provide 3 different datasets from 3 different centers to enable the reproducibility of radiomics, or give publicly available data to the people who are interested in phantom studies in radiomics. However, I see that the digital phantoms will be the future on this kind of experiments. So maybe in the next step for our work will be to introduce artifacts, technical artifacts, with the electron density or something else, or the Hounsfield units or something else.
And should you maybe consider 4D phantoms that have, reproduced the motion of a tumor or something?
That's highly esteemed opponent. That's an interesting notification, yes. Maybe as a next step, the 4D will be interesting, but for the radiomics reproducibility purposes, I do think that 3D is enough. But for other studies, for other purposes, yes, 4D will be the future.
Okay, thank you very much. In my second question, we're in your final chapter, your discussion,
Yes.
and I'm going to quote something that you wrote. You said a lot of emphasis has been placed on the ability of algorithms to make accurate predictions, but there is no understanding on whether humans are even able to understand the causal mechanisms underlying the input data used in AI-based technologies.
Mm-hmm.
Sounds a bit dangerous to me, and certainly also to patients as well, I think, if they hear this. And we also know that in diagnostic imaging, for example, that AI has not really been living up to the great promise that it had in the beginning. And I was personally involved a little bit with trying to make an algorithm to detect COVID, patterns. And the truth is that even today, there is not a single hospital in the world that dares to use AI methods to detect COVID. So this is kind of a broad question, but also your underlying statement, I guess, in your whole thesis that making the data fair is going to improve this a lot. But I didn't find a lot of hard proof in your thesis to support this. So is it just because it's very early days, or is there still a lot of promise there, or is this going to be the magic thing that makes AI work?
Highly esteemed opponent, thank you very much for your comment and question. You are pointing two separate things here, I guess. First is the point of my discussion, and second is about the, let's say, implementability or the implementation of AI in the hospitals. So for the first one, I had this statement because according to my experience, I have first to when I start an AI experiment in radiotherapy, I first have to understand the data and how the data, which is the structure of the data, and first define the clinical question and hypothesis for it. So for this reason, I said that we as humans first, we have to understand the AI and the data as well. For the second one, for the COVID case, to be honest, I don't have any experience, but for radiotherapy, I do see that for specific applications like the automated treatment planning or the automated contouring of organs at risk, many algorithms are implemented in many hospitals. But FAIR can help with it in terms of interoperability. I focused on the interoperability mainly in the last chapters of my thesis, and specifically for the proton therapy case. So FAIR, it's in, let's say, in its early days in the hospitals. It's not adapted for many hospital resources and for many hospital systems. So I tried to give some examples, especially from radiomics data, where I transformed the data into a machine-readable format in chapter 4. So I tried to give a basic understanding of how FAIR works, basically, in my thesis. So my goal was not to give a hard proof of it. I have a hard proof example in chapter 5 with radiomics, where we exchange data, statistical data models between two hospitals, where we had a problem that one hospital was not able to make the data available. So I tried to give an example of this. But yes, FAIR can help, but it's in the early days now.
Okay. Yeah, thank you very much for the discussion. I give the word back to the prorector.
Thank you very much. The opposition will now be continued by Professor Dumontier, who was also a member of the assessment committee and is a professor of data science at the Maastricht University. Professor Dumontier.
Thank you, Pro-Record. Dear candidates, so I wanted to first congratulate you and your promotion team on this very nice written thesis. I did enjoy it. I find it a compelling investigation into the theory and application of the FAIR principles in radiotherapy. And that has good potential for long-term impact. I'd like to organize my questions along two key axes. The first is about the machine learning that you have done, and the second about the FAIR principles. In your thesis and in your presentation, you indicated that patient characteristics were one of the reasons why the performance in the test case was not very high. But I guess I'm curious as to how you came to this deduction. And I would like you to think a little bit also, or comment about the growing availability of explainable AI methods and how that could potentially improve our understanding of how these models work and what we could do to mitigate them.
Highly esteemed opponent, thank you very much for your question and your comment. So I have the statement that the data nature of the data set characteristics are crucial for the training and the validation because except the technology that of each sender, the data sets maybe contains outliers or bias. So for this reason, we have in chapter 7 highlighted that the different technologies that we have in different senders played a crucial role on this, because the model in the US was not good, was not fitted well in our dataset, in the Maastricht clinic dataset, because we have different technology on the treatment machines for radiotherapy. However, explainable AI can give some solutions on this. For example, deep learning or for radiomics, for the radiomics case, can give us more explanation about the, let's say, the feature, the way that we extract features instead of the traditional machine learning radiomics. So I do think that explainable AI will open a new, let's say, road for machine learning.
Mm-hmm. Did you ever have a chance to explore some of these libraries that are now available to interrogate the models and to give some insight?
To be honest, I didn't investigate it deeply in my thesis because I was focused more on the traditional machine learning.
Sure.
But I think that the next steps on these models, specifically for the probability-based model for the Bayesian network, is the way to go.
Yeah. Okay. Thank you. Yeah. Also, the lab that you come from also is quite engaged in federated learning activities, and I'm sort of curious as to how a federated learning framework could also facilitate improved portability of these models that you're building.
Hi, esteemed opponent. Thank you very much for your comment. Yes, so our group is focused mainly on the federated infrastructures and the federated learning of these models. So the overall goal is to learn from the data of other hospitals, overcoming the boundaries of data exchange barriers and the ethics approvals of hospitals to exchange data. So the overall goal is just to exchange statistical models without exchanging data. So, but we have as a goal to learn from these models and therefore from the data that are not exchanged, but the data that trains, the statistical trains are exchanged. So that's the overall goal.
Mm-hmm. Okay, great. The second set of questions lie around FAIR data principles. So, as you know, I'm one of the co-founders for the FAIR principles, so I'm certainly excited to see your work in terms of trying to implement the principles in this field. And I see a lot of good progress in the development and adoption of data standards, ontologies, data formats, and even generating knowledge graphs and providing them. You indeed sort of emphasized that your goal was more about interoperability, and that is one of the components. But the other is about accessibility and persistence of these data resources. In my investigations, I had the opportunity to see if I could explore the Sparkle endpoint that you had provided, but it was not available at the time. Now, it turns out that more than 50% of Sparkle endpoints are not available anymore between the period of 2010 and 2020. And I'm just curious as to your thoughts as to how we should aim to persist resources, life sciences resources, clinical resources, to fulfill this FAIR vision.
Hi, esteemed opponent. Thank you very much for your comment. So, unfortunately, during the submission of my thesis, after the submission of my thesis, we got a notification from the ITs of our department that the Sparkle endpoint URI is not available anymore due to privacy issues. But it's a general truth that most of the endpoints, of the Sparkle endpoints, are not available, half of them at least. So I do foresee, but we're working on it just to find another solution on how to facilitate this Sparkle endpoint in another location. However, I do foresee that the next steps for, let's say, establishment or the durability of this aspect of accessibility will be to have a standardized framework for, let's say, the admin or the legal procedures that should be taken into account for this, because we should write protocols of how to access the data. You can see it in the chapter where I have the public available data that we had to establish a protocol on this. So I do foresee that we have to spend more time on the methodology of how to implement accessibility, because the A principle, according to my opinion, is the most, let's say, time-consuming in terms of administration or legal issues that we have to overcome.
Yeah, well, indeed, just as interoperability can't be done by a single individual, perhaps neither can accessibility. All right, thank you very much for your answers. I give the word back to the prorector.
Thank you very much. Then the opposition will be continued by Dr. Kazmierska, who is also a member of the Assessment Committee and head of the Radiotherapy Department of Greater Poland's Cancer Center in Poznan.
Thank you very much. Dear candidate, thank you for opportunity to read your thesis. It was a pleasure for me as a clinician. I found it very interesting, less hermetic, and much more understandable for people like me who are not specialists in medical physicists or even in AI, but we are going to use AI tools in daily clinic. My first question refers to chapter 6 and 7 of your dissertation, where you discuss problem of external validation and ability to generalize knowledge by predictive models, considering unobserved confounding factors. You also state, based on available studies, that it's arguable to which extent such models need to be generalizable and should be adjusted to the implementing clinic. I'd like to know how you see the future of predictive AI models as a uniform model for everyone, for every center, or maybe the local ones, special for the department, special developed for the one department or even one clinic. So maybe to be provocative, do you think that we need external validation for this model at all?
Esteemed opponent, thank you very much for your question and comment. Indeed, in these two chapters, I focused on the external validation, independent validation of AI models. So I highlighted the importance of, let's say, first, data availability, second, to first understand the nature of the data, and third, if there is a potential or a possibility to transform this data into a fair format, because, to be honest, we had as a goal to implement distributed learning across the participated centers. We are already in discussions for it with external centers. However, I do believe that independent validation is highly, highly important for the generalization of these models. We have seen that, for example, in the proton therapy case, the clinical integrated models work but needed an update. For this reason, we have established a framework across all the different proton therapy centers in the Netherlands to continuously validate and update these models. If I understood your question well, you asked me if I'm in favor of external validation or not, or is it something different? Because I do agree that we should externally validate these models, but I do prefer the federated learning models because we don't exchange data and it saves us a lot of time in terms of administration to exchange these data models without exchanging data, because we need to sign and spend time on data sharing agreements or the extraction of data from radiotherapy departments or different hospitals is really, really difficult for many reasons. So I do agree that, yes, external validation is highly important, but in a federated learning manner.
Yeah, I agree with you. External validation is important, but do you see any way how to individualize the model, for example, for a clinic in Poland, who is quite different than clinic in Netherlands?
Yes.
You know.
I do foresee that the implementations of FAIR principles can solve this issue, can help to solve this issue, because we use, let's say, some definition of terminologies used in this data. For example, we have seen that between different hospitals, the same, let's say, data item has a different definition between two hospitals. And that's crucial. So first, before we perform an external validation study, we should first understand the data items, and the way to go, I believe it's by using ontologies or terminologies on this.
Yes, thank you. And the second questions, I think it's not a very difficult question. How would you address the problem of missing data in databases? I think as you are physicists, so it's not a difficult question.
Sorry, I didn't hear what
How do you address the problem of missing data in databases?
Esteemed opponent, thank you very much for your question. That's a really nice question. And so we have seen that we have a lot of missing data in radiotherapy department. First, the problem, I think, is originated from the registration of this data into the electronic health record systems of hospitals. So we have seen that a lot of different people are registering data in different, let's say, fields within the hospital systems. So I do foresee that each hospital should apply or adopt standardized way of registering data. That's what we are doing now with the proton therapy registry in the Netherlands. However, we do see that we have some problems regarding the missing data that we have. So we are working on it for, let's say, in a standardized manner for registering data as a first stage of the data registration, because the doctor or the physicist has, let's say, an Excel file or a CSV that before he or she takes this CSV table in his hands, there are multiple steps before that. So I do foresee that a standardized way of, let's say, imaging archive or imaging archives or electronic health record systems should be the way to go on this.
Mm-hmm. Okay, thank you. I think that together with the medical physicist or data scientist, we still have the problem to overcome in the future, a problem of group of patients who are missing in a database. For example, patients lost from follow-up. So this is the problem in Poland, but I know there's no easy solution for that. So,
esteemed opponent, yes, indeed.
Short answer, please.
yeah, sure.
Yes, indeed, it's a problem, and for this reason, I'm in favor of adopting the FAIR principles, and as well to, let's say, for this reason, I had the chapters and one chapter where I was introducing the FAIR principles, and I highlighted that the hospital stakeholders should take some action items.
Thank you very much.
Okay, thank you. Then the opposition will be continued by Professor Van Vulpen, who is a professor of radiation oncology at Leiden University. He is also a member of the assessment committee, and he is here present online. Please use your...
Sorry?
Use your microphone. It's okay.
So this candidate, I would first like to compliment you on your expressive and extensive thesis. I read it with great pleasure. And also I would like to compliment your co-promoting team with this achievement. For me, I would like to discuss with you chapters 9 and 10 on the proton therapy part. I think they are excellent chapters, and but they focus more on a model-based value proposition, which is of course really important. For me, also looking at the different graphs somehow gave me rest to see how the data structure is built up. So for me, very important chapters. But if I may read a part out of the discussion in page 213, just above 11.9, there you mention, as mentioned in previous sections of this work, a significant percentage of clinicians consider AI as a black box approach, without understanding the basic clinical and statistical concepts behind building a prediction model. And then you say, clinicians should have a leading role in the design of a prediction model, as they fully understand the clinical question. It has to be investigated with the involvement of data professionals. So I was a little bit concerned with this part. So how does this solve the black box?
Highly esteemed opponent, thank you very much for your comment and question. So in chapters 9 and 10, we focused more on the creation of data structures creation for the proton therapy data items from the National Proton Therapy Registration. So for the creation of these knowledge graphs, a collaboration was required between clinicians and the data scientists for the final result of it. Before the creation of the knowledge graphs, clinicians created the standardized data lists, which contains the specific data items that should be included for the proton therapy registration. So I do think that the black box I mentioned in the discussion of my thesis, it goes to the building of this knowledge graph and not to the clinical question definition or hypothesis. So the black box goes to, let's say, much more the technical stuff rather than the clinical one.
So, but that black box actually is a problem, as you described. Therefore, I think the solution you mentioned in this sentence is a complex one. So first, you say they fully understand the clinical question, but do they? As, for example, all the models being built earlier, all the data being collected are not like there is some kind of an overview or like there is a goal of where they want to go. So can you make an example of where you can show that they fully understand the clinical questions?
Highly esteemed opponent, thank you very much for your comment. From my experience, yes, I have an example. It's on the chapter where I describe the model-based approach validation we have performed in our clinic. So I had a difficulty to understand how for example, the dysphagia model is built, because I couldn't see in the initial paper a description of the feature selection method that was used, how the features were selected, and why these features were selected for this model. However, in the initial paper of this model, it was highlighted that the features were selected by the clinical experience of the physicians that are stressed with this specific model. So I do understand from this description, and I do understand from the external validation I've done, that of course the clinicians play an important role, and they do understand the clinical questions behind the, let's say, output of this model, the clinical output prediction of this model.
For me, it's also a little bit difficult to understand, because for my opinion, always when people say their clinical experience, it's sometimes, so therefore it's not easy to describe it in predictors. So I'm always a little bit scared. So when clinical experience somewhere is in the lead here, so aren't clinical questions really easy? You do not want any toxicity, you want cure, and a very good quality of life. So what is it where such a model, for example, on dysphagia, needs extra attention from those clinicians, just to understand how they build a model?
Esteemed opponent, yes, exactly. First, they have to understand the clinical purpose of building a model. For example, for the dysphagia case as well, I have highlighted the difference between the clinicians, the way of clinicians scoring dysphagia. So that was one of the reasons that this model needed an update in terms of coefficients in our center. Although it worked quite well, the performance was good. So I have seen that maybe these differences I had described before on the explainability on the way they score the dysphagia is crucial. So clinical experience is indeed needed on this model's development.
Well, I question this a little bit, because I think the scoring should be done by the common toxicity criteria, or a subset which is actually not, which must be clear for everybody, also not clinicians. But why would you give the clinicians a leading role, as you describe here? Why not better policymakers or philosophists or the astro chairs? So why should clinicians have a leading role in designing this?
As a clinician, can you come to a short answer, please?
to be honest, because they have fully access to the datasets.
Thank you. Thank you, Professor van Vulpen.
Thank you, Mr. Corey.
We continue the opposition with, and then have to look where we are, Professor Oya Bayan, who is a professor of data infrastructures in Germany, Cologne, and she is a member of the assessment committee.
First, I would like to congratulate you, and it was very nice for me to read your thesis and application of fair principles in a very challenging domain. My first question is about your choice of RDF and knowledge graphs as a verification method. You know, there are different methods of verifications, there are different standards. I would like to discuss a little bit on pros and cons, because in your thesis you also mentioned that there are different challenges. For example, when you are using this for registries, there are heterogeneous clinical workflows or data analysis pipelines, or also like mapping is quite subjective. Each individual might map differently to this knowledge graphs, terminologies. So how do you see the advantages and disadvantages of RDF in this complex domain?
Highly esteemed opponent, thank you very much for your common question. So, in the chapters where I created the knowledge graphs, we followed a standardized way to do this. So, we have available some ontologies that are focused in radiotherapy data and generally in radiation oncology data. And we try to implement a standardized technical part on this using a mapping language between the relational database and the RDF standard as an output. We selected RDF because it offers flexibility and the structure of RDF is interoperable between the radiotherapy centers. So they can be, let's say, slightly easily adapted from some participating centers. However, there are some other standards like fire profiles or some other data standards like OMOP. So to be honest, we tried to find the most suitable standard for our case, which is radiotherapy data case. For this reason, we selected this RDF standard and the ontologies we used for the creation of these knowledge graphs.
You mentioned the flexibility. Yeah, indeed, knowledge graphs offers the flexibility. How much of this, how much of the flexibility have been used? Like, did all clinical centers report to the same data set created to the same knowledge graph, or were there differences between the knowledge graphs they provided?
Highly esteemed opponent, thank you for your comment. So we tried, in this case, in the proton therapy registry case, to follow the standardized data registration items. So we have, as a use case, a standardized data collection. Then, a center of all these three participating centers should take an initiative to follow. For example, we took the initiative to follow these ontologies and the technical algorithm that transforms the data into the RDF format to adopt them from all the participating centers. So, yes, I do think that there must be an initiative from at least one technical profile of all these participating centers to follow a standardized framework. Of course, with the necessary discussions and the technical analysis from all the technical people involved.
Maybe I can do a follow-up question. One of the characteristics of this domain is this richness of the data, actually. Also, you mentioned in your thesis there are very different data sources, like imaging, prescriptions, letters, treatment planning. I think that you gave an overview in your thesis as a figure too. How much of those different data sources you could verify, and what were the challenges for those you left out?
Yes, we have different data sources, imaging, radiomic, and clinical data sources. So we have to deal with EHR, electronic health record systems, PACS, the imaging archives, and let's say the local archive of our department to store this data. So we have to deal with multi-source data from the hospitals. So the main difficulty was to first adapt these data items coming especially from the imaging source to a fair format, because it is not generally, let's say, it is not generalized. It's not a standardized way, and it's not adopted from other centers how to adopt a specific framework to adapt this verification style, especially for the imaging part, for radiomics, focusing on this point.
And like this computational workflow in radiomics is quite complex to select these features. How do you see this complexity, how it impacts the reusability of this data? Because like reusability also related to describing protocols of the acquisition of the data. If we have such a complex workflows, complexity can impact the reusability.
Please, a short answer.
Highly esteemed opponent, thank you for your comment. So I will give you an example for one chapter where I have the standardization steps of acquiring first and extracting a radiomic feature focusing on the imaging part. So I have several steps where they try to describe how the feature extraction is being taken, which protocol is taken into account in chapter 3, as far as I can remember. Five.
Okay, thank you very much. Then we continue the opposition with Dr. Lobo Gomez, also a member of the assessment committee and a senior scientist here at Maastricht University.
Dear candidate, first of all, I would like to congratulate you on your promotion. It was a pleasure to read your thesis. I really enjoyed it. I would like to ask my first question, continue on the previous subject, and specifically about having the data as triples and in a triple store, which means that then the researchers will need to use Sparkle to query it. But, however, not many researchers speaks the Sparkle language. How do you see that?
Esteemed opponent, thank you very much for your comment and question. Indeed, it was quite a challenge for me to address this issue in my paper where I was describing the Sparkle endpoint concept. I received a lot of emails from people who didn't understand how to use the Sparkle language. For this reason, I have given some examples of Sparkle queries that can extract this data from the RDF triples format. And I have some educational material attached on the supplementary material of the paper. However, I do foresee the difficulty for the non-technical people to adapt this concept, because it's quite complicated if you don't have any idea from coding or triples of RDF triples. So it's indeed a challenge, and I do see that with the, let's say, educational materials that are available in the scientific literature, this barrier can be overcome.
And do you see that something could be done to sort of try to hide that, and having something else in between that, let's say, the researchers would you expose like an API, a REST API, that it's more easy to understand how to use, and actually sort of hide some of the Sparkle queries? How do you see that?
Esteemed opponent, thank you for your comment. I do foresee that all the, let's say, verification steps made to be from the relational database to the last endpoint should be automated. For example, as I have mentioned before in the previous question, the algorithm that we used for the transformation of data from relational database to triples is really demanding and time-consuming because the researcher or the data scientist has to write a specific piece of code to transform this. So I do foresee that the next steps will be to, let's say, simplify this procedure using different APIs or an interface that could help mostly non-technical profiles to use and adopt this concept.
Okay, thanks. You also mentioned fire in the discussion quite extensively, and I was wondering why not you did choose to transform the data to triples. Why not to go to fire? And also, second question there, if you transform your data, if you decide to use the fire standard, do you think you are then FAIR compliant immediately, or how are your views here?
Esteemed opponent, thank you for your comment and question. So for the first part of your question, we didn't adopt FAIR. We didn't transform the data according to FAIR profiles because we investigated this case, and for our radiotherapy case, for our radiotherapy data items, the FAIR profiles were not, let's say, mature enough to be adapted for our case. And for the second question, that's a really good question. I do think that, yes, you are fair if you adopt FAIR, because somehow you are focusing on the reusability, right? And if you are not having the first three principles, you cannot have the R.
Yeah, with FAIR, you actually, to me, it seems that you tackle already the four, the F, the A, the I, and the R. It might be the future.
Yeah.
But so let me move on now. I really enjoyed. Okay, I really enjoyed specifically chapters 8, 9, and 10. And in chapter 8, it was sort of a managerial paper where you actually said, okay, how should, what are the whole of each stakeholder in applying FAIR to the radiotherapy field. And you have the project with the proton centers in the Netherlands. What have you learned when you tried to apply what you described in chapter 8? What have you learned so far? What works, what doesn't work, and how can we move on?
Esteemed opponent, thank you for your comments. So, from my experience, I have learned that the first part, where you have the admin procedures, like to have all the data, extraction approvals, or the ethics committee approval, it's the most time-consuming. So we should focus more on this in terms of time frame. So that's the most time-consuming part, and of course the data extraction from the different sources of the hospital.
Okay, thanks.
Thank you very much. Then we will continue the opposition by Professor Valentini. Professor Valentini is a radiation oncology from Rome. And for those who do not know the history of Maastricht, the original name of Maastricht was Trajectum ad Mosam, and that's the name given by the Romans who built this city 800 years ago. So we are very honored that he made all the way from Rome to Maastricht 800 years later again. Professor Van.
Thank you. It was an easy trip now. Anyway, I really would like to thank Petros for the contribution that he already gave to our scientific field with a large number of publications that you collect in your thesis. And according to your Greece origins, in a Socratic framework, you challenge the architecture of knowledge in a field, radiotherapy, take into account this new technology, AI. The architecture of radiotherapy has 4 steps right now: prescription, delineation, planning, and delivery. Can you summarize your thesis as a support that the hypothesis where we are going to is to have only two future steps in radiotherapy? One step is prescription, prediction, and planning only, and delineation only, one step, and the second step is planning and delivery. Does your thesis support this new architecture in radiotherapy, considering the contribution of AI to polarize only in these two steps?
Highly esteemed opponent, thank you very much for your comment and question. So my thesis mainly tried to give an overview of how AI can help on these four steps you described. But according to my experience, the crucial one is and the most time-consuming is the planning. So I do see that a lot of people spend much more time, for example, in planning, like when you are delineating the organs at risk, for example, it's a time-consuming task. So I try to focus on these gaps. So radiotherapy, according to my opinion, is a chain. So we have to focus on the weak links of it. But with these two different sets you mentioned now, I do foresee that we should more focus on the second one using AI.
Great, but I consider that your thesis support a lot this hypothesis, because with radiomic we can merge prescription, prediction, and delineation. And with delivery, having the QA control, as you are in some way already explored, that would be possible also to manage the planning of the day in a very efficient way. So I think that you are really supporting the future with your thesis. So, but as usual, we as protagonists didn't realize it, but now you have to do what is the planning, the landing point for radiotherapy according to your job.
Highly esteemed opponent, thank you very much for your comment. So, to be honest, I did see that we had a gap in the scientific literature, especially on the QA step of the treatment planning. So we have seen that it's still immature in the radiotherapy field, the implementation of AI techniques for the QA of radiotherapy. So to be honest, my personal goal will be to expand this work on this specific domain of radiotherapy, because it's still in the early days.
Thank you.
Thank you. Then there is one more minute for the prorector to ask one of the people to read proposition 11, please. You can stand up.
The word is the expanding Greece. Greece is the shrinking word. Victor Hugo.
It's a long time that I was at secondary school and learned this history. And I know, all we know, that bombs are falling at Kiev today as we speak. So what is the meaning of this proposition in 2022? What do you think Victor Hugo meant by this proposition?
Dear Prorector, thank you very much for your question and comment. So I included this statement in the propositions, of course because I'm Greek, but the purpose of it was that was a bit philosophical. To be honest, during my academic journey and my, let's say, primary, secondary, and high school years, I've learned, and especially in the university when I had a course called Philosophy of Physics, I learned a lot of, I had a lot of knowledge regarding the data acquisition, the knowledge acquisition in the early ancient years. So the last years, unfortunately,
as a non-Greek, you can make a short answer, please.
Yes. In the last few years, there was, let's say, a crisis in my country in terms of knowledge acquisition, and a lot of people brought this knowledge outside Greece. So that's the meaning. That first we took, let's say, the knowledge, and then we export it, which is not good for my country.
Okay. Thank you very much. Petros Kalendralis, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and our return in this room.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes. In the meantime, let's take a closer look at Maastricht University's renowned teaching method, problem-based learning. Once the pro-rector reconvenes the session, we'll tune in and continue the live stream.
Problem-based learning, or PBL. What does that mean exactly? 3 of my fellow students and I will show you around. Every week, we analyze a different case or issue together. We discuss the case and everyone can contribute different perspectives to the group discussion. If we get stuck, our tutor helps us out and suggests what we could do next. I prefer going to the library to prepare. Here, I can focus and I have quick access to books or journals that help me understand the case. Today, I can also train my stitching skills in the Skills Lab, where you can immediately put into practice what you've learned. After a day like this, I like going to the gym to clear my head and get ready for the next day.
At UM, you meet people from all around the world. Hello guys. Some of them are doing their exchange semester here, and they often say that PBL helps them learn and retain things very easily. I can understand why. It's a very active way of learning because you have to bring your own perspective to real-life cases. You have a lot of freedom to manage your time, your studies, your hobbies, and your work. Of course, that also means a lot of responsibility. Right now, for example, I'm arranging my exchange semester in Madrid. How cool is that? In this group session, we're the managers who have to allocate the resources of a real company. This is how we put into practice what we learned this morning. Studying here means being proactive and learning to plan well. Prioritizing and performing well under stress are great skills that help you develop as a person. But now, it's time to grab a coffee at the Student Service Center.
Right now, we're at the Brightlands Camelot campus. Here we can apply knowledge from lectures and tutorials in a practical setting. This helps us understand what we have learned and further develop our lab skills. Today, we're determining the amounts of cholesterol in various products. What I really like is the project periods at the end of each semester, where we complete a full research project. That includes planning, collecting data, analyzing, and presenting the findings. That way we learn how research works and we're able to see what it's like to be a real scientist. After practicals, I have to write a lab report that also helps me process everything I have learned today. UM has a lot of learning spaces where you can work on your own or with other students. This evening, I'm meeting my friends for a movie night organized by the MSP Study Association.
If you study law, you have to read quite a lot. Not all information is relevant, so you learn how to easily find the information you need to solve your case. In the afternoon, I have to give a presentation, so I like to practice it with a fellow student. Later today, a lawyer is giving a lecture. This will help us better understand the case we're working on. Speaking in front of a group is quite exciting the first time round, but you get used to it quickly. And having to present helps you also to adopt knowledge better. What I like the most is that we sometimes get to enter a plea in front of a real judge. These moot courts are really exciting. Now it's time for drinks with friends. Studying is important, but so is relaxing once in a while.
Petros Kalendralis, the degree committee here present has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Dekter is authorized to confer upon this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
But before I do this, you have to make me a promise. Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
Then, by the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Petros Kalendralis, the degree of doctor, and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee, and affixed with the official seal of the university.
Dr. Kalendralis, first of all, my sincere congratulations on this outstanding achievement, successfully defending your PhD and being granted the title of doctor. I believe that I speak for all three of us if I say that I'm very proud of you. It's no easy feat to successfully complete a PhD in 3 years rather than 4, especially considering that we've had a big pandemic to deal with. So, really good job. You've developed yourself into a strong, independent academic throughout these years. You're particularly strong in writing and planning, I think. Research papers just seem to glide on the paper at light speed. You're also a very strong communicator, and these traits will make your future academic career a little bit easier, hopefully. Speaking of your future career, I'm very happy that you were able to stay in our group. As a postdoc researcher, I think you're a very good addition to our senior researcher group. You're already taking charge of the IDAVA project and are transitioning well into postdoc life with writing grants, papers, and managing projects. A few highlights of the past few years that are worth mentioning. First of all, your fondness of Greek food, is to be expected. But what I recall mostly is your dislike toward Dutch Greek food. It's of course difficult to compete with your mother's food, which I understand. I always really admire the food you bring when you come back from Greece. You always bring meatballs and spanakopita, I believe. And the office kitchen always smells amazing when you show up with your mother's food. I also really enjoyed our conversations when you would sit across from me at Inigo's spot. We talk about anything, childhood, friends, family, COVID. You've also told me many lovely stories about your parents especially, and I'm really sad that they were not able to join today. But I'm certain they are very proud of you. Another thing definitely worth mentioning is how well you did at conferences. So at the Astro conference this year, you had 2 presentations, which got a lot of attention and questions. And this also got you an invitation to a special issue, which is really impressive. Even more impressive, though, is your achievement at Astro, which is the American version of Astro, where your abstract was rated in the top 5, which is a really big achievement, I think. As a result, you will soon travel there and present your work once again to the whole community that your thesis is based on. And on a personal note, I also asked our colleagues what they think of you. Many of them told me that they think you're a lovely and thoughtful person, and that they very much enjoy talking to you, either about research or about your personal life or their personal life. This is very much appreciated by many, including myself. I've also heard quite a few funny stories, such as the breaking beds story, and also recently when you were stranded in Groningen, and your great decisiveness in renting a car coupled with great hesitance to get on a scooter and drive to a rental agency was something that I heard I believe these highlights show how much you've achieved and how much you've grown in these past few years. And again, I am very glad that you will be able to continue with us. So my congratulations.
Thank you.
Dear Dr. Kalendralis, also on behalf of the Maastricht University, I congratulate you with the degree you have acquired, and of course also the promotion team. And unfortunately there is not so much time to discuss with you all your propositions, so we'll do one at the reception. There will be a reception, so you can leave the room, then we will make a picture here so that we also have the external people on your picture. Then we will go and join you at the reception. And for me, I would like to discuss with you at the reception your proposition 4, because we have a lot of crises in the world, I think, and you added one which was a complete new one for me. We are in a reproducibility crisis.
Yes.
I didn't understand a word about that one. And then you say that we need multidisciplinary radiotherapy groups. And I didn't learn you quite well, but I had some background information, and I think you're one of the people who can help the world with your multidisciplinary discipline to solve more crises than just the one of reproducibility, I hope. And then we close this session and go to the pictures.
Congratulations, man. You did great.
Yeah, give it to me.
Give it to you?
Give it to me.